Far beyond the orbit of Mars, something unusual entered our solar system. Not a planet, not an asteroid from our neighborhood, but an interstellar visitor. Scientists labeled it 3I-ATLS, an object that did not form with the Sun, did not grow up with Earth. It came from another star system. And then, something strange happened. Its path changed. Not because of engines, not because of impact, but because it passed near the most powerful gravitational force in the solar system, Jupiter. A planet so massive it doesn't just orbit the Sun, it controls traffic. Jupiter can capture comets, eject objects from the solar system, or fling them inward at terrifying speed. This raises a dangerous question. Could Jupiter's gravity turn 3I-ATLS around and send it back toward the inner solar system, toward Earth? To answer that, we need to understand how gravity really works and why Jupiter is not just a planet, but a cosmic bouncer. Why Jupiter controls the solar system. Jupiter is enormous, more massive than all other planets combined. Its gravity is so strong that it shapes the architecture of the solar system. Jupiter, the gravity king. If the Sun is the ruler, Jupiter is the enforcer. Anything that enters the outer solar system must pass through Jupiter's territory. That includes comets from the Kuiper Belt, asteroids from the outer regions, interstellar objects passing through. Jupiter doesn't need to touch an object to change its fate. Its gravity alone is enough. The gravitational slingshot. When an object passes near Jupiter, it enters a complex gravitational dance. Depending on the angle and speed, three things can happen. 1. The object slows down and gets captured into a new orbit. 2. The object speeds up and gets ejected from the solar system. 3. The object is redirected inward toward the Sun. This is called a gravitational slingshot. The same technique space agencies use to send probes deeper into space. But in nature, there is no mission control, just physics. Why interstellar objects are vulnerable. Objects like 3I-Atlas are especially sensitive. They arrive at high speed. Their orbits are not stable. They are not locked into the Sun's gravity the way planets are. That makes them easy targets for Jupiter's influence. A small change in trajectory far from the Sun can become a massive change closer in. Past examples. Many long-period comets did not start out near Earth. They were redirected. Some were sent inward after close encounters with Jupiter. Others were kicked out forever. Jupiter acts like a filter. Only certain paths survive. The key question for 3I-Atlas. For 3I-Atlas, scientists are watching its velocity, its closest approach to Jupiter, and its incoming angle. Because if the geometry is right, Jupiter could bend its path, not into a collision, but into a return trajectory, one that brings it back toward the inner solar system, and possibly near Earth's orbital neighborhood. This does not mean impact, but it does mean proximity, and proximity is enough to demand attention. In the next part, we'll look at exactly how close 3I-Atlas comes to Jupiter, and whether simulations show a return path toward Earth is actually possible. The Jupiter encounter. What the trajectory models show. When scientists track an object like 3I-ATLS, they don't rely on a single prediction. They run thousands of simulations, because gravity is simple in theory, but chaotic in practice. Mapping an interstellar path. 3I-ATLS entered the solar system on a hyperbolic trajectory. That means it is not bound to the Sun. It did not originate here. It is moving extremely fast. Unlike comets from the Kuiper Belt, this object is just passing through. But passing through doesn't mean unaffected. Jupiter changes everything. As 3I-ATLS approaches the outer solar system, one planet dominates every calculation: Jupiter. Jupiter's gravity is so strong that even a distant encounter can reshape an orbit. Scientists focus on one key moment: closest approach distance. A difference of just a few thousand kilometers can completely change the outcome. 3 possible outcomes. Current models show 3 realistic scenarios. 1. Minor deflection, most likely. Jupiter bends the path slightly. 3I-ATLS gains or loses a bit of energy, but continues on its way. After passing the Sun, it exits the solar system forever. This is the most common result in simulations. 2. Ejection at higher speed. In some cases, Jupiter acts like a slingshot. It transfers energy to the object. 3I-ATLS leaves the solar system even faster than it entered. This happens if the encounter angle is just right. 3. Inward redirection, rare but possible. In a small number of simulations, Jupiter redirects the object inward, not into a collision course, but onto a new path that crosses the inner solar system again. This is the scenario that attracts attention. Why a return is so hard. For Jupiter to send 3I-ATLS back inward, several conditions must align perfectly: precise approach angle, exact velocity range, correct timing relative to Jupiter's motion. Miss any one of these, and the object escapes. Nature doesn't aim, it rolls the dice. Small changes, huge effects. Here's what makes this fascinating. A tiny gravitational nudge far from the Sun can translate into millions of kilometers of difference closer in. This is why simulations are constantly updated. As new observations refine position, speed, direction, predictions become sharper. What scientists are watching now? Astronomers are closely tracking changes in velocity, orbital curvature, timing of the Jupiter encounter. Each update slightly shifts the probabilities, but so far, there is no model showing a direct Earth impact. Why this still matters. Even without danger, this encounter is scientifically valuable. It shows how interstellar objects behave in planetary systems. Giant planets shape cosmic traffic. Solar systems protect and expose inner worlds. Jupiter is not just a planet, it is a gatekeeper, and 3I-ATLS is a rare test of that role. In the next part, we'll confront the biggest fear directly. Could Jupiter's gravity ever send an object like this close enough to threaten Earth? Could 3I Atlas actually reach Earth? After understanding Jupiter's power and analyzing the encounter geometry, we arrive at the most important question. Could 3I Atlas actually be sent toward Earth? The short answer is direct impact is extremely unlikely, but the long answer is more interesting. Earth is a very small target. From a cosmic perspective, Earth is tiny. Even when an object enters the inner solar system, the chance of a direct collision is extraordinarily low. Space is vast. Orbits are precise. A small deviation usually means millions of kilometers of misdistance. What sent toward Earth really means. When scientists say an object could be sent toward Earth, they do not mean a straight-line collision. They mean the object's new orbit may cross Earth's orbital distance, it may pass through Earth's neighborhood, it becomes a near-Earth object temporarily. This is very different from a guaranteed impact. Jupiter as both shield and threat. Here's the paradox. Jupiter protects Earth most of the time. It captures or ejects countless comets that might otherwise threaten the inner planets. But occasionally, Jupiter does the opposite. It redirects objects inward. This dual role makes Jupiter both Earth's bodyguard and, very rarely, the reason dangerous objects arrive. What simulations show? Current trajectory simulations indicate 3I Atlas is moving very fast. Its path is strongly hyperbolic. It is unlikely to be captured long-term. Most models suggest Jupiter will either slightly bend its path and let it escape, or eject it completely from the solar system. A clean return toward Earth requires a very specific geometry. Possible? Yes. Probable? No. Timing is critical. Another factor is timing. Earth must be at the right place at the right time. Even if 3I Atlas crosses Earth's orbital distance, Earth itself is usually elsewhere. Two moving targets rarely line up perfectly. Why scientists still monitor closely? Because interstellar objects are rare. Each one teaches us how other star systems form debris, how gravity reshapes trajectories, how planetary defense systems should respond. 3I Atlas is a test case, a rehearsal, not a threat. What this means for planetary defense? If a future interstellar object were on a concerning path, detection would matter, tracking would matter, and Jupiter's influence would be factored in immediately. This is exactly why scientists run these simulations now. The real takeaway is 3I Atlas is not a doomsday object. It is a messenger, a reminder that the solar system is not isolated and that gravity is always working behind the scenes. In the next part, we'll step back and ask a bigger question. What interstellar visitors like 3I Atlas are telling us about the galaxy itself? What interstellar visitors like 3I Borisova Atlas reveal about the galaxy. Objects like 3I Borisova Atlas are not just cosmic curiosities, they're messengers. They carry information from places we may never visit, entire star systems away. Not from here. Everything we usually observe in the solar system formed from the same cloud of gas and dust. Planets, asteroids, comets, they share a common origin. Interstellar objects do not. They were born around other stars. Their chemistry, their structure, their history, all different. When one passes through our solar system, it gives scientists a rare opportunity to study alien material without leaving home. Why they are so rare? Interstellar objects move fast, very fast. They don't orbit the sun. They pass through once and are gone forever. Most go unnoticed. Only with modern sky surveys have we begun detecting them. That means discoveries like 3I Borisova Atlas are just the beginning. There may be millions passing through that we never see. What Jupiter teaches us about other systems. When Jupiter interacts with an interstellar object, it gives scientists insight into something bigger, how giant planets shape star systems. In our system, Jupiter acts as a filter. It captures some objects, ejects others, redirects a few inward. Other star systems likely do the same, which means the architecture of a planetary system determines how safe inner planets are, including planets like Earth. Learning planetary defense without danger. 3I Borisova Atlas is not a threat, but it is a rehearsal, a real-world test of detection, tracking, and modeling. Scientists can ask, how early did we spot it? How accurate were predictions? How does gravity reshape its path? All without an emergency. That knowledge matters, because someday an object will matter. A window into other suns. Interstellar objects may contain different ice compositions, exotic minerals, clues to planet formation elsewhere. They help answer questions like, are other star systems like ours, or fundamentally different? Every visitor expands our understanding of how common or rare solar systems like ours may be. The solar system is not closed off. For a long time, we thought of the solar system as a quiet neighborhood, stable, isolated. 3I Borisova Atlas reminds us that the galaxy is dynamic, stars move, debris travels, and sometimes paths cross. The real meaning of this encounter. The story of 3I Berizova Atlas is not about danger, it's about perspective. Our solar system is not sealed off, it is part of a larger cosmic ecosystem, and gravity is the language that connects it all. In the final part, we'll bring everything together and explain why Jupiter sending objects inward is not a threat, but a sign of a system that has kept Earth safe for billions of years. Jupiter, Earth's shield, or a cosmic threat? For centuries, humans have looked at Jupiter with awe, a giant planet, a swirling storm, a world so massive it reshapes space around it. But when objects like 3I-Atlas enter the story, Jupiter's role becomes complicated. Is Jupiter protecting Earth, or could it one day be the reason danger arrives? The truth is both. Most of the time, Jupiter is Earth's greatest defender. Its gravity captures or ejects countless comets and asteroids before they ever reach the inner solar system. Without Jupiter, Earth would face far more impacts. Our planet's history would look very different. Life itself might not have survived long enough to evolve intelligence. The rare exception. But gravity is neutral. It does not choose sides. On rare occasions, the same force that protects us can redirect objects inward. Not intentionally, not maliciously, just following physics. Objects like 3I-Atlas highlight this balance. They show us how close the line really is between protection and exposure. Why this is not a cause for fear. Here's what matters most. The solar system has been doing this for over 4 billion years. Jupiter has always been there. Interstellar objects have always passed through, and Earth is still here. Impacts happen, rarely, but civilization-ending events are extraordinarily uncommon. Knowledge is the difference. Today, we can detect interstellar visitors. We can track them. We can simulate their futures with astonishing precision. We don't just react anymore. We observe. We understand. 3I-Atlas is a reminder, not a warning. 3I-Atlas is not here to threaten us. It is here to teach us. It shows us how planetary gravity shapes destiny, solar systems interact with the galaxy, Earth exists in a cosmic traffic flow. This object will pass, Jupiter will do what it always does, and the solar system will remain stable. The bigger perspective. Earth is not fragile by accident. It exists in a system that has quietly protected it for billions of years. Jupiter is part of that system. Not perfect, but powerful. The final thought. The universe is not hostile, it is dynamic. Interstellar visitors remind us that we are part of something vast, and that survival comes not from fear, but from understanding the forces that shape our place in space.